Let's do this example problem 2. A sinusoid current I of t is given by this expression. Now this is 0 at t equals to negative 625 microseconds and is increasing at a rate of 8000 pi amperes per second. What is the and given the maximum amplitude, what is the omega, what is the time period, and what is the angle phi for the cosine form? Okay, so a bunch of interesting information is given. Let us try to identify what is given first. Okay, first piece of information that we can use is that the value of this current is 0 when t is negative 625 microsecond. Let's park that information to one side. Then there is also information that at t equals to negative 625, so in other words, if I am to plot this, at t equals to negative 625, that value, negative 625 microseconds, the value is increasing, right? So the 0 can be in one of two situations. Think about it. When the value of the sinusoid is 0, it could be crossing in a downward direction or it could be crossing in an upward direction. Okay? But the problem specifies that this is crossing in an upward direction. Okay? It is increasing. That is what it means. Okay? Then there is another additional piece of information given, which is that the rate of increase is 8000 amperes per second. So I'm carefully color coding the different pieces of information here. Shown in pink is that at negative 625 there is a value of 0 for the wave, and at that time it is increasing. Okay, and then the rate of increase is 8000 pi amperes per second. Then the last piece of information given here is really that the maximum amplitude is 20 amperes. Okay, very good. Let's put together all of these pieces of information. Where do we begin? Okay, let us start by simply plugging in this I of t equals to Im cosine omega t plus theta I. Sometimes I use theta I, sometimes I use phi I. That's the canonical form in amperes, right? Let's simply plug in what we know right away. Okay, we know that Im is 20 amperes, so I'm going to simply write it as 20 cosine omega t plus theta I in amperes. So that is this 20 is coming from the maximum amplitude given. Okay, now where do we go? Let's use this blue piece of information. Okay, this one right here particularly, the rate of change. Okay, d by dt of I of t is given to be 8000 pi. Okay, so if I take d by dt of 20 cosine omega t plus theta I, that should all equal 8000 pi. Okay, because the rate of change, it is increasing at the rate of 8000 pi amperes per second. Okay, that's the piece of information I'm using here. Okay, I already used this piece of information. Now I'm putting to use this piece of information. Very good. Now, if I use derivative on this, it's going to give me 20. The derivative of cosine is negative sine omega t plus theta I multiplied by, using the chain rule, the derivative omega, okay, of the derivative of omega t. All of that is given to be 8000 pi. Very good. So we have put the second piece of information, which is the blue one, into use. Now let's use the, you know what, I'm going to color code here and then go by the piece of information here. T at t equals to 0, at t equals to negative 625 microseconds, the I of t is really 0. Okay, I of t is 0. So now what we should really understand is I of m cosine omega t plus theta I when t equals to negative 625 microseconds, all of that equals 0. All of that equals 0. Now, which simply means all of this term cosine omega t plus theta I, all of that equals to 0, because this is constant. The only way all of this term can be 0 is if this guy is 0, which means when is a cosine 0, omega t plus theta I equals to plus or minus 90 degrees. Okay, cosine of plus 90 is 0, cosine of negative 90 is 0, but I'm simply going to say omega t plus theta I equals to negative 90 degrees. And the reason I say it is negative 90 degrees is because we are delaying. Okay, we are delaying. Okay. Now, it could even be omega t plus theta I equals to 270 degrees as well. It can be negative 90 degrees, or it can be equivalently represented as 270 degrees. Okay, with the condition that it is going positive. Okay, now we have this piece of information. Okay, all of this is 8000 pi. Okay, all of this is 8000 pi, and then all of this is 270 degrees. Okay, so let's bring back this equation here, the 20 all of this guy. Okay, let's copy this, let's paste it over here. So I'm bringing this from the previous equation that we solved, 20 times negative omega sine times omega t plus theta I is 8000 pi. Okay, now pay careful attention. Oops, what happened there? I'm going to redo everything. Okay, now what we have is we have a value for omega t plus theta I. So this guy is 270 degrees. Okay, when I plug 270 degrees in there, okay, all of this, the sinusoid value, the sine of 270 degrees becomes negative 1. Okay, I could have plugged in negative 90 as well. I would get the exact same value. So by plugging in this piece of information, we have negative omega, negative 20 omega, okay, negative 20 omega times negative 1 equals to 8000 pi. Okay, and then omega equals to 400 pi, or 8000 pi divided by 20, which comes out to be 400 pi, or you can calculate its value to be 1256.637 radians per second. Isn't that sweet? What we have done is to use three pieces of information, maybe three pieces of information here, okay? Or actually, if you think about it, four pieces of information, okay? The fact that it is increasing, okay, is also factored in to the idea that it is negative 90. It is negative 90 or 270 degrees. Okay, negative 90 or 270 degrees. Now, let's see. So we plugged in, we used the information that the amplitude is 20. Then we used d by dt of this guy, d by dt of the sine wave, cosine wave, equate that to this guy. And then we also found out that by equating the cosine wave to 0, and then using this piece of information, we can get a value of omega t plus theta I equals to 270 degrees. Okay, so far we have been able to get an expression for d by dt of I, and then from that we got a value for omega. Okay, we got a value for omega. Then the next problem is easier to find. What is the next problem? Let's see. Next problem is, what is the time period? Okay, what is the time period here? Time period is easy to calculate. Time period is simply 1 over frequency. Okay, 1 over frequency, which is 1 over 2 pi. So f, 2 pi f is omega. Okay, f is omega by 2 pi. Okay, so that equals to 1 over omega by 2 pi. Okay, 2 pi by omega, we know the value of omega, which is 400 pi. Okay, so 1 over 200 pi, 2 pi over 400 pi, because that's the value of omega, right? So it gives us 1 over 200, which comes out to be some 5 milliseconds. Okay, everybody with me? So we are interested in calculating the big T, the time period, which can be calculated as 1 over f. 1 over f can be expressed in terms of omega, and voila, we have 5 milliseconds for that. Okay, what's the next part that we are expected to find out? We are expected to find out the value of theta I, isn't it? Let's see. What is the value of phi I or theta I? Okay, now if you think about it, what we just found out is that all of the cosine value, okay, all of the cosine value is 0. Okay, let's use this. Let's copy this. I'm going to copy this in order to find the value of theta I. Cosine omega t plus theta I is 0, which simply means omega t plus theta I equals to cosine inverse of 0 degrees. Okay, cosine inverse of 0 degrees, which is plus or minus 90 degrees. Okay, so we should be using really negative 90. Okay, we should be using negative 90. We are using negative 90 because we are thinking of cosine as being delayed here. Okay, we're thinking of cosine as being delayed. Your actual cosine would look something like this. Without a phi angle, at 0, time t equals to 0, the the peak would happen, the maximum amplitude would happen, but because we are delaying this, we are going to say the phase angle is negative there. Okay, the phase angle is negative, so we are going to use a negative 90 degrees. So omega t plus theta I equals to negative 90 degrees. Now we know the value of omega, okay, and we know the value of t, okay. We know the value of omega to be some 400 pi if I remember correctly, and then we know the value of t to be negative 625 microseconds, okay. We should be able to calculate theta I, okay. So omega t plus theta I equals to negative pi by 4. We are going to express everything in terms of radians because omega is angular frequency. Okay, now you can find out, you will find out eventually that when you, this is pi by 2, okay, you will find out eventually that theta I, plug in the value for omega, plug in the value for t, theta I is going to be negative 45 degrees. Okay, so once you plug in all the values, you'll see that theta I is negative 45 degrees. So in effect, we have calculated all the answers that we were expected to find. This is 5 milliseconds. This is negative 45 degrees. Okay, omega we found out to be 400 pi. Okay, we found out omega to be 400 pi. So that's a another example problem number 2.